So in this lecture, we will see how to use solver and Excel add-in product to find optimal solution given a linear programming model. We'll continue to use the Galaxy industry to illustrate this process. So here is the final formulation of the Galaxy industry. And of course, in order for the solver to find a solution for us, we need to transfer or feed all these information into Excel, which is the step 1. So this is done like this. So first we designate these two empty cells to store the value of the two decision variables, and solver will find the optimal solution and populate these two cells with real number at the very end, and then we simply transfer all the coefficients in our final formulation and put them in the corresponding columns underneath the two decision variables. So here, objective function 8 is the corresponding profit per dozen for space rate. 5 is the corresponding profit per dozen for zappers. And here we write down the 4 constraints together here. And we write down less than or equal sign here to serve as a reminder for ourselves that all these 4 constraints stipulates less than or equal to. And this column is simply transferring the constants on the right hand side of the 4 corresponding constraints into Excel. So notice so far we did not use any formula yet. We are simply transfer constants informations from the formulation into an Excel sheet. So once we are done with step 1, our next step, step 2, is to calculate the total profit and the value of left hand side for each constraint, and I will show you what I mean. So given these two cells stores the value of the two decision variables, the total profit, let me write down total profit here, knowing this cell stores the unknown optimal solution for the space rate. Knowing these cells will store the unknown value of the optimal solution for zappers, we know the total profit should be the product of these cells with these cells plus the product of these cells and these cells. And there is a formula called sum product in Excel that does just that. We need to choose these two cells as the array 1 for the first parameter, for the first argument for this sum product function, and then we'll choose these two cells as the array 2 for the second arguments, and then we close it with the second parenthesis and we hit enter, and then this cells becomes the sum product of these two corresponding arrays, and that is what we want it to be. And the reason that the value is 0 is because these two cells are empty as of now. So similarly, we will apply sum product the Excel function to calculate the value of the left hand side. So again, we'll choose these two cells as the first argument. We'll choose these two cells as the second argument, and we hit enter. So what this value says is, given manufacturing these two amount of space rates and zappers, given the coefficients of plastic consumption, this value will be the total amount of plastic consumed. And we can verify those two functions did what it's supposed to do by actually putting real number here. Let's say I put 10 dozens, 5 dozens respectively, and these two cells will calculate the corresponding profit and then the corresponding plastic consumed. So this way we verified these two formulas indeed do what they are intended to do. But again, remember, we'll leave these two cells empty for the solver to populate the correct optimal solutions. And so similarly, we will need to, okay, so let me name this column left hand side. So similarly, we need to apply the sum product for the remaining 3 constraints. We can do this by drag the formula downward. However, if you double click on the cell, Excel will actually show you the formula used and also the value of the two arguments. And notice, because we drag this cell downward for one row, the two arrays, the two array 1 and array 2 also move downward by one row, and that's how Excel behaves. But of course we know that we want the first array to stay put on the fourth row. So in order to do that, we can of course move this up, and we still also need to use another trick of Excel, which is a symbol, a $ symbol right before the 2, 4, to tell Excel I want to lock the first array at the fourth row. Now hit enter, and we can verify it actually works by dragging the same formula for the 2 remaining constraints. And again, we can click on one and verify it indeed locked the first array at the fourth row, again because we put the $2 preceding 4. And in this case, we only need to lock row, but in some cases, if you want to lock both row and column, you just need to put another $ preceding the designation of column. You can always hit escape to dismiss the information that was just shown. So after step 1 and step 2, now we will actually open Solver, which is the add-in Excel program to find a solution for us. So to do that, you go to Data tab and you click on Solver. And first thing we need to tell Solver is to identify the cell that store the profit, which is F7 in this case. And also we need to choose whether it is a maximization or a minimization problem. In this case, it's a maximization problem. And the changing cell, you can delete it and then choose again. The changing cell are the cells you designate for the decision variables. In this case, it will be D4 and E4. Now, next we will input the constraints one by one. We'll click Add to input the first constraint. So we will remember we have used this cell to store the value of the left-hand side, which is a sum product of the coefficients with the corresponding decision variable value. So this cell stores the value of the left-hand side of the first constraint, and it needs to be less than or equal to, in this case it has been chosen, to less than or equal to the resources available. In this case is 1,000, so we would click on this cell and click on this cell, and this way we completed the first constraint. So we just need to repeat the same process to input all the remaining 3 constraints. Again, I will hit Add. I will select this cell here. I will select this cell here. Then I'll add another constraint here, here, and then I will add the last constraint. Again, you need to be careful to choose the correct signs. Now it's done. Just click on OK. And so we put all the information here, but remember, there's one thing we haven't put in yet, which is the non-negativity requirements. So we'll click on Options. We'll leave these as is. We need to click 2 things. One, we need to assume this is a linear program, so we click on Assume Linear Model, and then we need to choose Assume Non-Negativity Constraints, and that's all we need to choose. And now it's time to just click on Solved, and that's it. It actually tells us solver found a solution. All constraints and optimality conditions are satisfied. And in addition to the answer we need, we also want the solver to produce the sensitivity report. Therefore, we highlighted these 2 reports, and then you click on OK. And now, here earlier, 2 empty cells have been populated with the correct optimal solutions. In this case, it will be 320 dozens of space rays and 360 dozens of zappers, which would optimize the profit given the 4 constraints plus the negativity constraint. And you can also look at the sensitivity report here on this tab and the answer report on the other tab.